I'm Doug Bundy, former president of ISIS. In this short video, I want to try to put Moray King's lifetime work, which has focused on the quest to harness the energy of the fabric of space, into the context of Dewey Larson's reciprocal system of theory, in which no fabric of space exists. I'm not going to try to explain the observed phenomena of ball lightning, EVs, or plasmoids in terms of an RST-based theory or model at this point, but rather my intent is to show how the legacy system of theory is wholly unsuitable to use as a basis for investigating these phenomena. And no offense is intended, Moray, by this, but it's what we it's what we stand for. That's the object of our organization, is to establish the fact that Larson's reciprocal system of theory is a revolution, a genuine revolution in physics. The bottom line is found in the unrecognized revolution in our understanding of the nature of space and time, which his work reveals so clearly. The fact is, the only known relationship of space to time is motion. And even though one can think about space-time, as Einstein did, and do things with it to a certain extent, in the end it won't work, as the LST's great theoretical crisis now shows. The ultimate reason, as Einstein knew only too well, is the fundamental incompatibility of continuous and discrete magnitudes. Though it's not widely known, Einstein actually would have preferred a discrete-based or algebraic physics, but he was unable to find a way to get to such a thing. He was convinced, as today's physicists are too now, after pursuing unification as diligently as he did, even though he was mocked for doing so at the time, they're convinced that the space continuum is doomed, as the famous string theorist Edward Witten puts it. In fact, according to the well-known theoretical physicist Arkani Hamed, the idea that the space continuum might not be fundamental is pretty well accepted in the LST community. But in his day, Einstein suffered alone, plagued, as he put it, with his thoughts that the assumption of a space and time continuum was probably the wrong approach, given that physical phenomena are quantized. Nevertheless, all the while, he is celebrated as the champion who revolutionized continuum physics. John Stachel of the University of Boston Center for Einstein Studies, who first discovered this other side of Einstein, explains, quote, "If one looks at Einstein's work carefully, including his published writings, but particularly his correspondence and memory of conversations with him, one finds strong evidence for the existence of another Einstein, one who questioned the fundamental significance of the continuum. His skepticism seems to have deepened over the years, resulting late in his life in a profound pessimism about the field theoretical program, even as he continued to pursue it." Close quote. The drawback is essentially that one needs to have a continuum in order to have a discontinuum. Einstein put it like this: "The problem seems to me to be how one can formulate statements about a discontinuum without calling upon a continuum as an aid. The latter should be banned from the theory as a supplementary construction, not justified by the essence of the problem, a construction which corresponds to nothing real. But we still lack the mathematical structure, unfortunately. How much have I already plagued myself in this way?" Close quote. Well, long after Einstein, the LST community found out the hard way just what he meant when they sought to unify their quantum physics or quantum field theory with Einstein's physics of the continuum. In fact, they have a term for it. It's referred to by them as the Vacuum Catastrophe. Let's let them explain it in this PBS video clip.
The most successful theory in all of physics is arguably quantum field theory. It's made the most precise predictions in all of science. But it's also made the worst. There's a massive disagreement between the theoretical and the measured values of the energy of the vacuum. We call this theoretical fail the vacuum catastrophe. The quantum vacuum is a seething ocean of activity. Virtual particles appear and vanish from nowhere in seeming violation of our intuitions about the conservation of mass and energy. We saw in our recent episode that we can thank the Heisenberg uncertainty principle for this bizarre behavior. It tells us that there's a quantum fuzziness in the amount of energy contained at every point in space, a non-zero, zero-point energy in the quantum fields that can briefly manifest as particles. This suggests that space itself contains energy. But how much energy? Quantum field theory predicts that the energy of the vacuum should be up to 120 orders of magnitude greater than the measured value. It's one of the greatest unsolved problems in physics.
The presenter in this clip goes on to help viewers grasp just how mammoth this theoretical fail, quote unquote, is. It's unimaginably huge. And the reason is, just as Einstein wrote, the idea of the fabric of space, as we've referred to it today, is nothing but a supplementary construction, quote unquote, that is unreal and should, quote unquote, be banned from the theory. The trouble is, of course, Einstein could never figure out how to do that, and neither has anyone else except Dewey B. Larson. Consequently, the LST community has swept this unfortunate fact under the rug, as Hamid admits in the following clip.
Imagine you got 50 zeros and you're still adding. So how dense is that? Let me give you an example. Yeah, I'm getting there. If you take a centimeter cube of space and you were to take all the stars in the universe we see with the largest telescope, billions of stars, right? There's billions of stars per galaxies. There's billions of galaxies. Most stars are much larger than our sun. Some of them are larger than our solar system. And we grabbed all, like quasars and stuff, and we grabbed all that stuff. We squashed it all into a centimeter cube of space with a huge trash compactor or something. Imagine how dense that would be. How energetic that would be, right? Well, you would still be off by some 39 orders of magnitude, right? Because you would have a cube of a density of 10 to the 55th grams per centimeter cube. So you'd be off by 39. You still need to add 39 zeros to get to the density of the vacuum, which is formally infinite, right? Do you think that the physicists that discovered this stopped and said, hey, maybe we need to consider this in our physics? No. They looked at that number and said, oh my God, it's actually called the vacuum catastrophe. It's like, oh, what do we do? Just ignore it, brah. That's if you're studying in Hawaii, you know. If you're here, you'd say, ignore it, mate. Little translation for you guys. And, you know, all this energy just got pushed to the side and said, put under the carpet and said, hey, you know, this is too overwhelming. This probably has no significant physical meaning. Huh? You just found the most massive amount of energy ever And you're saying it has no physical meaning? Most likely is the source of all physical meaning, brah. You know? If you're Hawaiian.
The words of Einstein should actually be ringing in the ears of the LST community physicists. They should be hearing, ban the continuum from the theory. Ban the continuum from the theory. But of course, they can hardly do that at this point. The key to solving this awful dilemma, however, the key offered by Larson, is actually hidden in plain sight. But the LST community physicists can't see it because it requires independent investigators with no investment in a career of theoretical physicists or physics to invest the time and energy necessary in order to seriously consider such a radically new paradigm. In this new paradigm, vector motion, or the one-dimensional motion of objects changing relative positions in space, is not the only motion of nature. Besides this one-dimensional change of motion, which is the sole basis for modern physical laws and theory, there also exists multi-dimensional change of interval motion and multi-dimensional change of scale motion to consider. And without recognizing this fact, the LST community is left to chase down rabbit holes in the labyrinth of the continuum. Nevertheless, while the solution can only be sketched at this point, all indications are that the mathematical structure which Einstein pined for that would have enabled him to define a discontinuum without the aid of a continuum is now at hand. Although, to be sure, he outlined major conceptual obstacles with both concepts. For instance, he wrote the following on the discontinuum. Yet I see difficulties of principle here too, he wrote. The electrons as points would be the ultimate entities in such a system of building blocks. Are there indeed such building blocks? Why are they all of equal magnitude? Is it satisfactory to say God in his wisdom made them all equally big, each like every other, because he wanted it that way? If it had pleased him, he could also have created them different. With the continuum viewpoint, one is actually better off in this respect because one doesn't have to prescribe elementary building blocks from the beginning. Further, the old question of the vacuum, where they're talking about Michelson-Morley's experiment that was very big then. There's no ether. But he goes on to say these considerations must pale beside the overwhelming fact that the continuum is more ample than the things to be described. Well, in this last sentence, unquote there. So in this last sentence, he perfectly articulates his understanding of the vacuum catastrophe of quantum field theory, which was yet to be fully appreciated in his day. But the answer to his concern for how to prescribe elementary building blocks from the beginning, which caused him to hesitate in favor of it, in spite of the overwhelming fact that the continuum is obviously too ample, is now at hand. Larson's RST has made it straightforward. So, as usual, Einstein was right on when he observed, quote, one does not have the right today to maintain that the foundation of physics must consist of a field theory in the sense of Maxwell. The other possibility leads, in my opinion, to a renunciation of the space-time continuum and to a purely algebraic physics. So, that's close quote. So where does that leave us as members of ISIS? Well, we still have ZPE to consider as a source of energy to be tapped. It's just that it doesn't exist at every point in the vacuum, the so-called fabric of space, because there is no such fabric. Instead, our redefined concept of space is simply shown to be an aspect of an unrecognized type of motion, scalar motion. We start with it and find that by simple principles, unit building blocks of what we could call ZPE emerge with which to build matter, with no background needed. Just how we get from these units of ZPE as elementary building blocks of matter, from the ZPE to quarks and to leptons and to baryons and on to atoms in the wheel of motion, and from there to the molecules of chemistry, and from there to ball lightning, EVs, and plasmoids, is a work in progress. But we've had enough success to give us great confidence that the anomalous energy that we see and that Moray will be explaining consists in the motions, combinations of motions, and the relations between them that are now under development. The point is, we are not stuck by the vacuum catastrophe, as Steven Weinberg puts it in his book, Dreams of a Final Theory. A final theory is no longer just a dream as we awaken to the reality that physical objects and physical phenomena consist of nothing but motion existing in 3 dimensions with 2 reciprocal aspects, space and time. We now know that, as Larson put it, all we observe is either a motion, a combination of motions, or relations between them. With this much understood, then, as we listen to the remarkable discoveries of modern-day Michael Faradays like Ken Shoulders and Walter Jenkins, and all the others whom Moray King has studied over these many years, we can hope that a modern-day James Maxwell will come along to integrate it all together with a new mathematical insight that will revolutionize the world once again. In the meantime, however, we should understand and be sure that the needed paradigm shift is not a shift from the classical physics of Maxwell's continuous field equations to the quantum physics of Dirac's discrete field equations, but from the physics of the LST's impossible concept of space-time to the physics of the RST's new concept of expanding space over its inverse, expanding time. Thank you.